This problem is about chi-square goodness of fit test. It's a goodness of fit test because we have only one variable. It has 5 categories, but we have only one sample. One variable and one sample is a goodness of fit problem. The first question that we're asked is to complete the table. That means we want to put in the expected frequencies. That's all they're asking us for when we complete the table. The problem tells us that the claim is that all 5 categories are equally likely to be selected. So that means that the total number of observed responses, or whatever it is that we're observing in each category, the total number of observations, should be divided equally among the 5 categories. If we add up the observed frequencies, we get a total of 61. If I divide those 61 observations equally among 5 categories, that's going to be 61 divided by 5, I'm going to have 12.2 observations in each category for my expected. So we're going to have 12.2 in each one of the categories. Now, just looking at the observed frequencies and comparing those to the expected frequencies, clearly categories A and E are close, but the 3 in the middle are really not that close to 12.2. So probably that claim is not going to turn out to be true, but we're actually not going to look at that in this one. We're just going to answer these questions. So if our expected frequencies are 12.2, now we're asked to calculate the chi-square statistic. The chi-square statistic for each category is equal to the observed number of observations minus the expected number of observations, and we're going to square that difference and then divide by the expected. And we need to do that for each one of our categories, for all 5 of our categories. For category A, that means that we're going to have 15 minus 12.2, and we're going to square that, and then we're going to divide by 12.2. And if we do that calculation, we're going to get 0.643. If we do the same thing for categories B through E, that would be 7 minus 12.2 squared divided by 12.2 for category B. And that's going to give us 2.216. For category C, 7.872. For category D, 4.249. And for category E, 0.00327. If I add all these up, including category A, I'm going to get 14.984. And generally, your calculator or some computer software would do most of this for you. But the chi-square statistic, the answer to the question 2, should be 14.984. Let me know if you have any questions from this one.